just read out to you, they are just they cover all the key stages. When you think about it, they cover all of the key stages. So these are topics that I know when I said I was going to do part two, I know that it was to do with the primary school, year 4, 5, 6, 7, 8, and 9, but it covers right across from year 1, reception year 1, right through to year 11. And I'm sure you're thinking, reception year 1? Well, reception year 1s, they can count in steps of 2s. They can count in steps of 5s. That means they are counting in multiples of 2. And it also means they are counting in multiples of 5. So never, never underestimate the ability of a young inquiring mind. Whether the pupil, the child is in reception year 1, their brains are ready to soak up learning. And that's what the math show is all about. Dean has just come into the studio. You know who Dean is? Dean is the maestro who produces and does all the drawings and the graphics and all the social media. And he's just given me a copy of the Sovereign Comics, Mr. Numbervator, one of our latest comics, okay? I'm going to show it on screen. This is what it looks like. And it's called Let's Get Mathematical. And inside of this comic, we have got other comics in the Mr. Numbervator comic range, and they've all been put together into one comic. But what I'm loving about this comic is that it's on Amazon. You can actually buy it on Amazon. Yeah, you can get it on Amazon. Just go to Amazon, put in Sovereign Comics, put in Mr. Numbervator, put in Isaac Anoom, you're going to get it. But look at the graphics. Just look at what Dean has done, yeah? That is amazing. And I was in a primary school just yesterday in Edmonton, and the young people were saying, Mr. Numbervator, did you draw all of those drawings? I said, no, it was done by Dean. And now they want Dean to go into the school and show them how did he do all of these graphics. And I particularly like the colors that Dean has used. I like the light blue and I like the contrast. I think that's the sort of yellow sandy color. That is a really, really lovely front cover. So please, 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 you know where to go. Amazon, Sovereign Comics, Mr. Numbervator, Isaac Anoom, and you'll be able to purchase your own comic of Let's Get Mathematical. Parents, teachers, carers, everything you need to know about mathematics is contained in this one comic. So I'm going to promote it again later on, but if I was you, during the break, go online, order your copy, and then come back to the show. Okay, let's get on with the show. Let's start off with prime numbers. We're looking at place value, and we're looking at number, and we're looking at the influence of place value and number on our mathematical learning. We're looking at the impact of knowing and being secure and confident with number. And we're going to do a deep dive into understanding about number. So prime numbers. What is a prime number? Well, let me approach the answer this way. Every single number in our counting system, has got at least two factors. One, and the number itself. So every number that you can think of in our counting system can be divided by 1 and the number itself, at least. Now, so you've got some numbers that can only be divided by 1 and the number itself. They are called prime numbers. And the opposite of prime numbers, that is numbers that have got more than two factors, are called composite numbers. So you've got prime numbers and you've got composite numbers. We're looking at prime numbers to start our math show today. A prime number is a number that is greater than 1, but can only be divided by itself and 1. So a prime number is a number that is greater than 1 and can only be divided by itself and 1. So I'm going to throw out the number 4. Is the number 4 a prime number? Let's investigate. Right, so what numbers do I know can divide equally? That means with no remainders. How many numbers do I know can divide into 4 with no remainders? Right, I can think of 1, 2, and 4. So that means the number 4 has got 3 factors. That means the number 4 is a composite number because a prime number has only got 2 factors. So 4 is what we call a composite number. Let's look at the number 3. Is the number 3 a composite number or is it a prime number? What do I know about the number 3? I know that 3 can be divided by 1, and I know that 3 can be divided by 3. There are no other numbers that can divide into 3 equally apart from 1 and 3, which is the number itself. So that means 3 has only got 2 factors. And that also means that 3 must be a prime number, because a prime number has only got 2 factors, 1 and the number itself. So we now understand what a prime number is, and we now understand what we call a number that is not a prime number, and that is called a composite number. So let's look at our first 5 or 6 prime numbers in our counting system. So we know that it has to be greater than 1, so we don't include 1. So let's look at the number 2. 2 can be divided by 1, and 2 can be divided by 2. So that has got 2 factors. So that must mean 2 is a prime number, and it is. But do you know what? 2 is our only even prime number. Can you imagine that? 2 is our only even prime number. And I find that really amazing. It's the only even prime number. So we're going to start with 2. We've got 2 as a prime number. We know that 3 is a prime number. We know that 4 is not a prime number. It's a composite number because it can be divided by 1, 2, and 4. So it's got 3 factors. So after 4, let's look at 5. 5 can be divided by 1 and 5, and that's it. So it's only got 2 factors. So 5 must be a prime number. So now we've got 2, 3, 5. Let's look at the number 6. 6 can be divided by 1. It can be divided by 2. It can be divided by 3. And it can be divided by 6. So 6 has got 4 factors. So that means 6 is a composite number. And that means 6 is not a prime number, because it's got more than 2 factors. So this is when I talk about a deep dive into understanding number and place value, this is exactly what I mean by a deep dive. Now, some of you, if you're teachers, parents, you might have heard that phrase deep dive, because maybe in your children's school, the head teacher is doing what we call a deep dive into mathematics. That is looking at how maths is taught, looking for any gaps and shortfalls and so forth. Ofsted, when they go into schools, they do deep dives. They pick a certain topic, a certain subject. It could be art, it could be music, it could be anything. And they focus in on that particular subject. But with me on the math show, I'm taking a deep dive into place, value, and number. I'm giving you all of the understanding, all of what you need to know about number and place value. And I've just taught you about prime numbers. So let me recap. A prime number is a number that's greater than 1, and it can only be divided by itself and 1. We know that 2 is a prime number. We know that 2 is the only even prime number. We know that 3 is a prime number. We know that 5 is a prime number. we know that 7 is a prime number. So it looks like all of the other prime numbers are odd numbers. Now that's interesting. That could be a little investigation for you tomorrow morning in school. Are all odd numbers prime numbers? Have a little think. Are all odd numbers prime numbers? Now that is a wonderful investigation. It's a wonderful investigation to get your teeth into. Because I know 3, 5, 7, 9, 11. Oh, no, I made a mistake. Let me start again. I know that 3, 5, 7, 11, 13, they are all odd numbers and they are all prime numbers. But 9 is not a prime number. 9 is not a prime number because it can be divided by 1, 3, and 9. It's got 3 factors. Now, I slipped up because as I was saying 3, 5, 7, I automatically knew the next odd prime number after 7. And I said 9, but that's not the case. So we all make mistakes. I put my hand up. It was a mistake. I've corrected myself. I've explained the mistake. We can move on. And this is what learning is all about. Never be embarrassed. Never be scared. Never be worried about saying the wrong answer or about making a mistake when it comes to maths. There's nothing wrong with that. We can learn from mistakes. We can all learn from mistakes. I've given you a challenge for tomorrow morning at school. Are all odd numbers prime numbers? I can imagine some of you are shouting at the radio, you've made a mistake, you've made a mistake. They're not, well, I'm not going to say anything. If you want to get back to me and answer the question before the end of the show, you know the number to call. I'm going to say it now. 07535 644 850. 07535 644 850. Dean, I'm going to put Dean on the spot. Dean, come to the mic, please. Dean, what do you think about my question? Are all odd numbers prime numbers? Now, that's the question that I'm asking young Dean. Now, you know that when Dean's in the studio, we have lots of fun because Dean knows that I love to get him on the show and I just love to show him off when it comes to his maths ability. Because remember, not only does he do all the graphics and all the drawings and writing, but Dean, while he's doing all the drawings and writing, he's learning about maths at the same time. So, Dean, are all odd numbers prime numbers? What do you think?
I have a question. Is it something that you have to know just through experience and knowing all of the prime numbers?
No, you can actually work it out.
Work it out.
Yeah.
Okay. All right,
because what I've said to you earlier is that let's take the number 7 for example. Yeah, it's an odd number. Yeah. Right, 7 can be divided by 1 and it can be divided by 7. Yeah. It cannot be divided by any other number without any remainders.
Yeah.
So that's how you can work it out. So what you can say to yourself is, whatever number you're thinking of, what factors can divide into that number, and then that will tell you whether it's a prime number or whether it's a composite number.
Okay, all right then.
Yeah. Okay. So will you come back to us later?
Well, I've got an answer already.
What's the answer?
No.
Why do you say no?
Because if you're listening very closely, you gave one of the answers a little bit earlier.
Ooh.
Yeah. So
what did I say?
I'm not going to repeat it. Maybe you'll have some callers who could answer it better.
Or someone to send me a message, maybe.
Yeah.
So now did you hear what Dean just said? By mistake, he says that I gave the answer without realizing. So later on, we're going to call Dean back to the mic and we're going to find out the number that Dean is thinking of. Thank you, Dean.
Okay.
Now, isn't that interesting? I'm on the radio, I'm teaching maths on the math show, and without realizing, I gave an answer to a question that I gave after I've given the answer, because that's what I do. And that is what maths is all about. The other day, I was talking to Blaze, and Blaze is the main presenter on Chalkhill Community Radio. And we were talking about money. and we were talking about the cost or something. And Blaze was looking at the actual money amount itself. And there's me, the money that she gave, the money that we were talking about. I started saying, oh, Blaze, did you know that amount of money can be divided by 3, 5, 11, whatever? And she just cracked up laughing. She said, trust you, I'm talking about money and going spending. And what are you doing? You're talking about maths. But money is maths, and that's what I do. But thank you, Dean. So Dean will come back later on. So we know what a prime number is. We know 2, 3, 5, 7. We know that it's not 9 because 9 has got 3 factors. And then you've got 11 and you've got other numbers that follow. Brilliant. So that's a prime number, 2 factors only. A non-prime number is what we call a composite number. So 4 is a composite number because it's got more than 2 factors. Brilliant. Square numbers. What is a square number? Yesterday, only yesterday, I was working in a school, and I was, what I like to do, I like to go into a school where the teachers watch me teaching their own children. So they watch me, and they observe me. They look at the way I'm engaging with the young person, how I'm sustaining that engagement. They're looking at my mathematical vocabulary. They're looking at my use of manipulatives. They're looking at the way that I get children to record and to team talk and to partner pair talk and so on. And I was teaching some year 4 children about square numbers because year 4 children in June of next year, June 2026, they will be sitting their MTC, which is called the multiplication tables check. And that is a times tables check to see how much they know with the multiplication tables so that when they start year 5, they start year 5 confidently. So I was teaching them about square numbers, and all I did was I drew a square on the board. That's all I did. I drew a square on the board. So one young boy said, why have you got a square on the board, Mr. Numbervator? And I said, because we're looking at square numbers. And he said, yeah, but numbers aren't square. I said, let me show you how numbers can be squares. So what I did was I drew 3 dots in a line. I drew another 3 dots underneath those 3 dots. And I drew another 3 dots underneath those 3 dots. So I had 3 lots of 3 dots. I had 3 rows of 3 dots, and I had 3 columns of 3 dots. I then joined the 4 corners together. Now, instead of using the word corners in the year 4 class, I used the word vertices because vertices is the more mature vocabulary for a corner in maths. So I drew the 4 corners, and I made a square. And this same young boy, his eyes lit up, and he went, 3 lots of 3 equals 9. So you've got 3 rows, and in each row you've got 3, and you've got 3 columns, and in each column you've got 3. So 3 lots of 3, that means 3 plus 3 plus 3 equals 9. I said, yes. And then he said to me, you're multiplying the same number by itself. And I then said, yes, you're multiplying the same digit by itself, just to be mathematically friendly and correct. So 3 times 3, the same digit you're multiplying by itself gave me 9. So I said to him, what does 2 times 2 equal? And he drew 1 row with 2 dots and another row with 2 dots. And he joined the corners together, the 4 vertices. He made a square. I then said to him, 2 times 2 is 4, 3 times 3 is 9. What is 4 times 4? I don't know. Draw it, represent it, show it to me. So he drew 4 rows with 4 dots in each one. He added them up and he got the answer 16. That is square numbers. That's why they are called square numbers. So he went on to tell me 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6. He might not know the answer to 6 times 6 or 7 times 7, but he knew how to draw the rows and the columns. In mathematics, we call it an array. And the word array, A-R-R-A-Y, comes from the word arrangement. An array is an arrangement. So he knows how to draw 4 lots of 4s, 5 lots of 5, 6 lots of 6, and then he knows how to count the dots, and he's going to get the correct answer. So this is what square numbers are. You're multiplying the integer by itself. Now, I've used the word integer because an integer is any whole number. So now you understand what a square number is. Why? Because when you represent it visually, it makes a square. Is it maths? Is it maths beautiful? Is it maths amazing? And I didn't have to keep on talking to the young boy about writing down 3 times 3, 4 times 4. He was able to draw my answer. And that meant so much more to him than me sitting down and saying to him, 2 times 2 is 4, 3 times 3 is 6, sorry, 3 times 3 is 9, 4 times 4 is 16. He was able to draw and show me the answer. And that made my day. And his class teacher was observing. And the head teacher came in and she observed what was going on. This is a year 4 pupil. He's only been in year 4 for a maximum of 4 days. And look at what he can do. I was so proud of him. So we've looked at prime numbers, square numbers. Let's look at factors. We've mentioned the word factors already. So what is a factor? A factor of a number is a number that can be divided into that number that is equal or smaller than that number. There's a lot of words that I've used there. Let me give you an example. Let's look at the number 12. I want to know what the factors of 12 are. That means I want to know what numbers can divide into 12 equally with no remainders. So I'm going to start from 1. I know that 1 can divide into 12 equally. I know that 2 can divide into 12 equally. I know that 3 can divide into 12 equally. I know that 4 can divide into 12 equally. I know that 6 can divide into 12 equally. And I know that 12 can divide into 12 equally. So that means 12 has got 1, 2, 3, 4, 6, and 12. 12 has got 6 factors. That means 12 is a composite number. It is not a prime number. It is what we call a composite number because it has got more than 2 factors. And I've just given you and explained to you what a factor of a number is. Once again, isn't maths amazing? Yeah, I'm telling you it is. And I'm proving it to you is this evening. It's getting dark outside. I remember back in February, March, I remember saying to Dean, and we were saying the sun is out at this time of night, it's shining, it's nice and bright. I did say in about 4 or 5 months' time, it's going to be dark at the same time. And lo and behold, it's starting to get dark already. What we call it dusk, D-U-S-K. Right, so what are multiples? Multiples are numbers from a particular times table, which is easy. So a multiple of 3 is a number from the 3 times table. For example, 3, 6, 9, 12, 15, 18, and so on. A multiple of 12 is a number from the 12 times table. 12, 24, 36, 48, 60, 72, and so on. A multiple of 7 is a number from the 7 times table. 7, 14, 21, 28, 35, and so on. So that's what a multiple is. It's a number from a particular multiplication table. So that's easy. So we've looked at prime numbers, square numbers, factors, multiples. Let's look at what we call standard form. Because standard form is a topic that is taught usually beginning of year 8 upwards. Some year 7s are taught it, especially if they're on track for higher tier, but usually year 8 onwards, we look at standard form. What is standard form? Standard form is a mathematical route. It's a mathematical way of writing very large numbers or very small numbers. So already you can see that in science and technology, you've got really big numbers that you're dealing with, and you've also got really small numbers that you're dealing with. Big numbers, for example, the distance from Earth to Jupiter, that is a lot of kilometers, yeah? That is a big number. And then when you're looking under the microscope at little tiny microorganisms, they are so, so small. We have to represent those as small numbers. So standard form is a way of writing really big or really small numbers. And there's a little formula that we use. And the formula is x times 10 to the power of something. So standard form, the number that you are using is always between 1 and 10. It can be a decimal number, but it's between 1 and 10, and you multiply that number by a factor of 10. So it could be 10 squared, 10 cubed, 10 to the power of 4, 10 to the power of 5, or so on. Okay, so you're multiplying the single digit by a power of 10. So let me give you an example. Let's take the number 87,000. That's a big number, yeah? You've got 87,000. And I want to write that number in standard form. I want to write it in a much more smaller, compact, tidy way. I don't want all these zeros all over the place. So I'm going to look at the number 87,000. And remember what I said, we're looking for a single digit that we can multiply by a power of 10 to help us get the answer. It can be it could be a decimal number. So it can be something like 5.4, 3.2 or something. But we're looking for that single digit. So if I take the number 87,000, I want to know how many place values do I need to go towards the left to get to my whole number. So if I've got the number 87,000, the decimal point at the moment is at the back. It's behind that last single third zero in the number 87,000. So how many places to the left do I need to go to get to 87,000 to a single digit? I've got to go 4 places. And then that gives me 8.7. So I've got 8.7 multiplied by 10 to the power of what? Well, because I went back 4 places, it's 8.7 times 10 to the power of 4. Or if I multiply 8.7 by 10, I get 87. If I do 87 times 10, I get 870. If I do 870 by 10, I get 8,700. If I do 8,700 by 10, I get back to my 87,000. So that's another way of looking at standard form. Yes, you can have negative. You can have 8.7 times 10 to the negative whatever power, but that's for another session. I'm just looking at the basic understanding of standard form. We can look at cube numbers. A cube number is like a square number, but instead of just doing the number by itself, you do it 3 times. So if you're looking at 4 squared, you would do 4 times 4. If you're looking at 4 cubed, you would do 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. So that is what a cube number is. Okay, we're going to have a really, really short ad break. And when we come back after the ad break, I'm going to be going over prime factors and the rules of indices. And then I must cover about cumulative frequency, box plots, area of sectors, and the area of a triangle using trigonometry. We've had a really fun, action-packed beginning of the show. Don't go anywhere. Don't go too far. I shall see you after the short ad break.
Are you a grandparent with a new baby?
Look at what these are. Look at this comment. This is amazing. Amazon. Wow. And we've got our barcode. Oh my days. That is really amazing. Oh my gosh. Wow. In here are 3 comics. 3 comics in one. 3 comics in one. You cannot go wrong. 3 comics in one. Absolutely brilliant. Absolutely brilliant.
You can also order it from any bookshop as well.
And you can order it from any bookshop. You can order it at sovereigncomics.co.uk. It's all over the place now. You can't go wrong. So get the comic. Get the comic. Look at the graphics. It is amazing. Absolutely amazing. Muted. Can you mute it?
With over 2.
I'm going to bring you in about.
Whether you want to learn about maternity rights or look for a school, whether you want to find out about flexible working or search for the right childcare, Direct Gov is the website to point you in the right direction. Hiring migrant workers who aren't entitled to work in the UK is illegal. If you're caught, you could be fined £10,000 per worker or face up to 2 years in prison. Catching hand on Friday, no questions asked, understand. It's your responsibility to check your workers' legal status.
Right, sir, I'm arresting you for working illegally in this country, and I'm arresting you also for employing this gentleman illegally.
Don't end up as illegal as they are.
Migrants was a more welcoming place in which to live, work, and travel.
My road will get a new cycling lane. Go to www.sovereigncomicsuk and get the latest issue of Mr. Numbervator's Maths comic book series today. You are now tuned into the Mr. Numbervator show every Wednesday from 5:30 to 6:30 p.m. on Chalk Hill Community Radio Station. Let's get mathematical.
Welcome back to part 2 of the Math Show with me, Mr. Numbervator, on Chalk Hill Community Radio Station. And it's the only radio station across the country, it could be even wider, I'd say across the world, where I am teaching you maths on the radio every week. You are getting a really full, well-balanced diet of mathematics every week between the hour of 5:30 and 6:30 on Chalk Hill Community Radio Station. Now, just before the ad break, I was talking to Dean. Everyone knows who Dean is. Dean is the maestro. Dean is the person who creates all of the characters. He draws them, he represents them, he models them. And on the comic that I'm holding in my hand, our latest comic, it's got 3-in-1. You can see the detail and the perfection of Dean's work. But Dean is also a mathematician, or he likes to think he's a mathematician. He's smiling. Now, I gave him a question, and I just said to him, Dean, do you think that all odd numbers are prime numbers? Because we looked at 3, 5, 7, 11, and so on. So I'm going to bring Dean in and ask him the question again. So, Dean, are all odd numbers prime numbers?
No.
Why do you say no?
I say no because you gave an answer earlier, but you also explained why.
And what was that answer?
The answer was 9.
Okay.
Yeah.
Explain to me.
Oh, the explanation. Okay, right. Yeah, it's because it you can also divide it. It has more divisors than itself and 1. Yeah.
Okay. It can be divided by 1, 3, and 9.
And yeah. Mm-hmm.
So can I ask you a question? Can I put you on the spot?
Okay.
We've got 2, 3, 5, 7, 11, 13.
Mm-hmm.
What is the next prime number after 13? Is it 15?
It's not 15. No.
Why is it not 15?
15 is another non-prime number.
Right.
Yeah.
And how do you know? Because it can be divided by 1,
1, 5, and 3. Yeah.
and
3
and 15.
and 15. Yeah.
So that's got 4 factors.
Okay.
Okay.
Yeah. Okay. So I was going to say 6. Is it 17?
Yes, it is 17.
Okay, yeah.
Brilliant. Why did you say 17? Why did you hesitate?
Yeah.
Why did you hesitate to
No,
say
because
17?
I was thinking some people have to take time to think. We're not all Mr. Numbervator.
Okay. I like that. I like that. No, but I just thought maybe you were worried about giving the wrong answer.
No, because I was thinking about 16, and I know that 16 you can divide it by 4, 8, 1 in itself.
And 2,
right?
yeah.
And 2, yeah.
Wow.
So,
oh my gosh.
Yeah.
Brilliant. Okay, well look, there you go. So thank you, Dean. Brilliant answer. So what the point I'm making is that anyone can get involved and engaged with mathematics. So I've got a comment here from a teacher who said that she's loving the fact that Dean has come to the microphone and explained what about prime numbers and so on. So that's quite interesting. That's from a teacher. So Dean, congratulations, she's saying. Okay, right. So the rules of indices. Now I'm always teaching about BIDMAS, BIDMAS. It's an acronym for brackets, indices, division, multiplication, addition, subtraction. It's about the order of operations. We do things in a certain order to get the right answer. It's across the globe. And the I for indices are basically like square numbers, cube numbers, numbers to the power of 4, to the power of 5, and so on. Now, we've got some rules for working them out that makes it a lot more easier to get to the answer. Let me give you a question. I've got the 2 with a little 5 above it, so 2 with a 5 to the right-hand side, multiplied by 2 with a little 3 above it, which is 2 cubed. So I've got 2 to the power of 5 multiplied by 2 to the power of 3. Now I can write down 2 times 2 times 2 times 2 times 2, and then multiply that by 2 times 2 times 2 to get an answer, and then convert that back with a power. But there's a much more logical and easier way of doing it. When you are multiplying with indices and your root number is the same, so I've got 2 to the power of 5 times 2 to the power of 3. I've got the 2 twice, so that's the root number 2. All you do is you add the powers together. So 2 to the power of 5, you add the 5, 2 to the power of 3, you add the 5 to the 3, and you get 8. So 2 to the power of 5 times 2 to the power of 3 is equal to 2 to the power of 8. And if you were to expand all of that, you get the right answer. When you're dividing with indices, let's just take 3 to the power of 10 divided by 3 to the power of 4. When you're dividing with indices, you subtract the index numbers. You subtract the power. So if you've got 3 with a little 10 above it, divided by 3, because it's the same root number, with a little 4 above it, 10 subtract 4 is 6. So the answer is 3 to the power of 6. Isn't maths amazing? Isn't it amazing? So that is the answer. And those are the 2 rules of indices. Right, I want to get on to the four areas that this young year 10 pupil asked me. I don't want to run out of time because I did promise him, and I know that he's listening. He's already sent me hands clapping already. So let me address his question. Right, cumulative frequency. Okay, right. A cumulative frequency table shows a running total of frequencies, i.e., frequencies are how many times something comes up. So when I was teaching this the other day, I said I was working with some year 9s. I said to some year 9s, imagine you go shopping and you go with your mum or your dad or with an adult or on your own, and in your trolley, you have got 4 items. So you start with 4 items, yeah? Now, as you're walking around the aisles, you might put another 3 items in. So you started with 4, you've put 3 in, you've now got 7. Yeah? So the frequency, well, the first frequency was 4. The next frequency is 3, because you had 4, then you're going to add 3. Okay, you've added 3 into the trolley. Then you walk around the supermarket and you might put 5 or something in. So you had 4, you've added 3, you've added 5. 4 plus 3 is 7. So the cumulative frequency will be 7 for those two numbers. And then if you add 5, 7 plus 5 is 12. So the cumulative frequency would be 12. Can you see it's a running total of the frequency? A cumulative frequency diagram reproduces this information as a graph. And when you're showing it as a graph, you have a certain way of presenting the cumulative frequency graph. The cumulative frequency is always plotted on the vertical axis, and the other data is always plotted on the horizontal axis. So all you need to know is that the cumulative frequency is always plotted on the vertical axis. I'm sure that's making a lot of sense to my year 10 pupil. So for example, let's just say I've got a table and it's showing the lengths of 40 babies at birth. Yeah, it shows the length of 40 babies at birth. So I might say babies that were between 25 centimeters and 35 centimeters, there was 4 of them. Babies that were between 35 centimeters and 45 centimeters, there were 7 of them. Babies that were between 45 centimeters and 60 centimeters or whatever, there was 8 of them. So I would keep adding up all of those frequencies, and that would give me my cumulative frequency. And I would plot on as a graph the frequency against the plotted against the upper boundaries. The upper boundaries, when I said between 30 and 35 centimeters in the first band, then 35 is what we call the upper class boundary. The next boundary might be between 35 and 45. 45 would be the upper class boundary. So the number that is the maximum number in that range, that is what we call the upper class boundary. And with the cumulative frequency graph, you are plotting the cumulative frequency against the upper class boundaries. And then you get a nice curve and you get a nice line. Okay, so that is what cumulative frequency is. To calculate cumulative frequency, you add the frequencies together. I've given you the example of going shopping with items. The upper class boundaries, they might be 35, 40, 45, 50, 55, and so on. So you plot them. With a cumulative frequency diagram, you are able to find the median. So remember when you were younger, you looked at mode, mean, median, and range. You are able, range is, mean is the same as average. You are able to calculate and find out the median, the average, the middle value, and what we call the interquartile range. Okay? What does the interquartile range mean? The interquartile range is simply a measure of how spread out the data is. So with the lengths of birth, it's telling us from 30 centimeters to 50 centimeters. That is how spread out the data is. That's all that it means. And the interquartile range, it gives you in a quarter, a half, and 3/4. That's how it gives you the answer. Okay? So, and the interquartile range becomes the difference between the upper quartile, which is the biggest, and then the lower quartile, which would be the smallest. So, how do we calculate the lower and the upper quartile and the median and the upper quartile and interquartile range? The lower quartile is a quarter of your total, is a quarter of the total of the cumulative frequency. So in my case, 40 babies, the lower quartile would be a quarter of 40, which is 10. So you would find 10 along the y-axis, which is the cumulative frequency. You'd go along to the curve that you've drawn, and then you would come down, and then you would find out where 10 hits the x-axis, the horizontal axis, and then that would give you your lower quartile reading. The upper quartile is 3/4. So 3/4 of 40 is 30. You'll find 30 on the cumulative frequency side, which is the y-axis. You go to the curve, you drop down, and then that will give you your range. And then the interquartile is the upper quartile, subtract the lower quartile, and then you've got your answer. Okay, the median is basically exactly half of your total cumulative frequency. So half of 40 is 20. So you go along cumulative frequency to 20, go along to the line, the curve, drop down to the horizontal, the x-axis, and then you can read off your answer. I hope that's helpful. So that is cumulative frequency. Box plots are just another way of showing cumulative frequency. Box plots are another way of showing the median and the quartiles of data. To draw your box plot, you need these 5 main areas. You need the minimum value, you need your lower quartile, you need your median, you need your upper quartile, and you need your maximum value. So you need your minimum, your maximum, your lower quartile, your median, your upper quartile, and then your maximum value. So let's just say I'm going to give you a range. I'm going to give you a range of numbers. I'm going to give you 9, 10, 10, 12, 13, 14, 17, 18, 19, 21, and 21. Let me say it again. 9, 10, 10, 12, 13, 14, 17, 18, 19, 21, and 21, again. So what is your minimum value? It's 9, because that 9 was the smallest number that I started with. What is your maximum value? It is 21, because that's the number that I stopped at. So already you've got your minimum value and your maximum value. Your median is the number that is exactly halfway in that line, in the sequence of numbers. So the number 14 is exactly halfway between 9 and the 21. So 14 is our median. To work out your lower quartile, there's a little formula, and the formula is, because I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, I've got 11 individual numbers. It's 11 plus 1 divided by 4. 11 plus 1 divided by 4 gives you 3. So your third number in that in those rows of numbers is 10. So that would be your lower quartile. And then your upper quartile is the 3/4 number, which is the 9th number. And then that would give you your answer as well of 19. Okay, so this is how you calculate those 5 areas, and then you would draw a box plot. A box plot looks like a bit like a cat's whisker. You've got the lower minimum value. You've got the upper maximum value. You've got 9 on the left, 21 on the right, and in between you've got a rectangle. And then with the rectangle, you've got the median, which is halfway. You've got your lower quartile, which is the first quarter. You've got your upper quartile, which is the 3/4, and that's what the box plot looks like. So that's really interesting. Right, area of a sector. Now, I love sectors. I love circle theorem. I love playing about with circles. So step number 1, to work out the area of a sector, you need to know how to calculate the area of a circle. The way that we calculate the area of a circle is by using pi r squared, pi times the radius squared. So when you've got a circle, you've got your radius, which extends from the center of the circle to the circumference, to the edge of the circle. That's your radius. Pi, as a numerical number, is 3.14. So to calculate the area of any circle, you do 3.14. If the radius is 4, 4 squared is 16. So you would do 3.14 times 16, and that would give you an answer of something like 52 point something. So that would be the area of your circle. Now, why did I mention that? I mentioned that because when you're calculating the area of a sector, you need to be able to calculate and to use the area of a circle. I'm just calculating 3.14 times 16 is 50.24. So I was very close. Brilliant. Right. So that is what the answer would be if it was a question. So to work out the area of a sector, you will be given a sector in a question. And with the sector that you're given, it will give you a particular angle amount. So let's just say you've got a sector And remember, a sector is a part of the circle. It's a piece of the circle, okay? It's not necessarily a slice, but it's a piece of the circle. Let's just say you've been given a sector and the angle in the sector is 144 degrees. And you've been asked to calculate the area of that sector. That means how much space does that sector take up out of the whole circle? Now you know the reason why you need to know about area of circles. So to work out the area of a sector, you need to know what fraction of 360 degrees, how much out of 360 degrees is 144, that's the angle that you were given, and then you multiply that by pi times radius squared. So you've got 144 divided by 360, multiplied by 3.14, multiplied by 16 if the radius was 4, okay? And then you get your answer. And that's the area of a sector. It sounds complicated, it sounds challenging when you think about it, but it's not. To work out the area of a triangle using trigonometry, trigonometry is about sine, cosine, and tangent. Trigonometry is the relationship within the right angle triangle between the angles and the sides. That's what trigonometry is all about, basically. To calculate the area of a triangle using trigonometry, you've got the formula, and the formula is A is half of AB times by sine of C. Right, let's just say you've got a triangle. So triangle, you've got a triangle, and your triangle has got 3 sides. Let's just say you've got one side that is 5 centimeters, and you've got another side that is 7 centimeters. They are both prime numbers, by the way. Okay, Dean, they're both prime numbers, yeah? They can only be divided by themselves in 1. So let's just say you've got 5 and you've got 3. Now, the angle in between those 2 side lengths, there must be an angle in between those 2 side lengths, okay? The angle could be, I don't know, let's say 35 degrees. So you've got one side that measures, let's say one side that measures 3 centimeters, another side measures 7 centimeters, and then you've got that angle in between the 3 and the 7, okay? To work out the area of that triangle, you would do half of A is 3, B is 7, or B can be 3, and it doesn't matter which way around because it's the same answer, yeah? Multiplication. So half of A times B, so you would do half as a decimal is 0.5, multiplied by 3, multiplied by 7, multiplied by sine of 35 degrees. That's how you'd work it out. Half is represented as 0.5 as a decimal. So it's 0.5 multiplied by 3, which is one side length, multiplied by the other side length, which is 7, and you times that by sine of 35 degrees. So you go to your calculator, work out what is sine of 35 degrees, and you times it all together, and you will get an answer of 6.02 centimeters squared. So the area of that triangle would be 6.02 centimeters squared. I really, really hope my year 10 pupil, and there's other year 10 pupils listening, I really hope that I've gone through and I've given you enough to be getting on with, yeah? If you need more input, you know what to do. Contact me, send me a message, send me a text, send me an email, give me a call. Thank you to all my listeners. Thank you so much for listening to the Math Show again this week. The numbers are continuing to improve. Thank you to Dean for coming to the mic and talking to us about prime numbers. And yes, he was correct. I did give him 9. So there you go, but he was listening. Just to remind you of the latest Numbervator Sovereign Comics comic. It's out, it's on Amazon. You can go to any bookshop and order it by the ISBN number. So it's all professionally done. It's been all professionally put together by Dean and by Paul and myself. So go and get your own copy. It is worth it. This is better than a birthday present. This is better than a Christmas present. It's better than an Easter egg. Get the maths comic. Have a great evening. I look forward to seeing you all next week. Thank you so much for listening to the Maths Show with me, Mr. Numbervator, on Chalkwood Community Radio Station. We looked at prime numbers, square numbers, factors, multiples, standard form, cube numbers, laws of indices, and then we looked at cumulative frequency, box plots, the area of a sector, and we looked at using trigonometry to calculate the area of a triangle. Have a great evening. Thank you and goodbye.